All right, thank you for joining me here tonight for the first take and the first try of tonight's podcast that we have yet to name. This is episode 0, the pilot, and if friends and family like it and want more, then I guess we're contractually obligated to write more.
Write more?
Write more. I spent all day writing instead of doing my job.
Who are you?
I'm Trevor, your dear friend Trevor. Trevor A. Carter. Follow me on ResearchGate or on LinkedIn. Those are the only social media I operate under. I am a forest ecologist, I guess, is my title. I don't really know. I'm getting a PhD, which I guess means I know things by now. I've written a paper or two. I study forest ecology in the western United States, mostly around carbon and plant biodiversity and other buzzwords that I use to try and write grants and get money. I'm not an expert in anything, but I am an expert in forest ecology and plant ecology and carbon. I'm joined here by the very lovely...
I'm your friend Alec.
Alec Sarche. Thank you so much for joining me.
Thanks for having me.
He is going to be my, I guess, co-host?
Layman. I think the way we think about this is I don't know anything and you do. And that's it.
That's a beautiful concept.
Yeah.
I love to live in a power dynamic.
That's what we're going for here.
A really harsh power dynamic.
Yeah.
We're joined
Teach me.
behind the scenes by Humberto Rojas, who is operating the camera.
What's up, buddy?
So thank you for being here tonight. So tonight I wanted to talk about spruce beetles.
Ugh.
You've heard of spruce beetles before?
Yes. Yeah.
Okay, that's a very negative sounding reaction. What do you know about spruce beetles?
Not much. So, okay. Immediately, I grew up in Colorado. I'm a Denver local, and my reaction to spruce beetles is extremely negative because what I remember is a really vivid sense experience of we would drive into the mountains in the winters in I think I called this my bar mitzvah era, between 12 and 15. So late 2000s. I was born in 95. And what we would drive past is hillsides in these winters of dead pine trees, coppery, almost like orange trees that 2 years ago, to our memory, were alive and well. And suddenly we were driving up to a ski area or going up to a hike somewhere, and all of these trees were dead. And my dad would go, ugh, and that's how I knew things were bad. And I was really scared of it and had this idea in my head that the forest would be gone forever because in our minds it was like an epidemic of these spruce beetles that were killing all of our precious trees, and we would have to make somehow kind of an effort to get them all back again.
Yeah, that's I think a very common take.
It was awful. It was really bad. We thought.
You say that, but did you know that these beetles are native to these ecosystems?
No.
So
what?
Yeah, right. So we think of
no, we thought they were an invasive species.
So they're not an invasive. There are bark beetles. So spruce beetles are a type of what's called bark beetle, and they're called the bark beetle because their habitat is just under the bark, but not right into the wood.
Yeah, they make now. There's a lot of furniture they sell in Colorado that's made of beetle kill pine, and you can see tracks that the beetles have left in the bark.
Yeah,
and it looks very beauuful.
It's absolutely.
But we're
beautiful.
all pissed about it.
Yeah,
because it killed all these trees.
They do kill the trees. So they do kill the trees. They actually eat the trees. So
Jeez.
What they're doing inside there is eating this thin layer of sort of alive tissue that's between the bark and the wood. And so actually a fun thing about tree trunks is there's only a little bit of tissue. It's like a thin layer in between the bark and the wood that's alive.
Oh. So
trees grow in two ways. They grow up through their leaves and their what's called their apical meristem.
Okay.
And they're just rapidly growing up and up and up.
Apical meristem.
But they also grow sort of out, right? So if you carve your name on a tree, which I don't recommend doing because
that's killing the same layer that the spruce beetles kill.
It's damaging the same layer, right? You could carve your name, but that name, where you carve it, isn't going to move up in space. It's going to stay in the same spot. It's just going to grow out, right?
Okay.
And so that layer that grows out is another layer that's alive in the tree. And
that make year by year a new ring of tissue.
Exactly. Yeah.
Okay.
And so that's their nutrients flowing down from the leaves, all of their photosynthetes.
The wood isn't alive?
No, the wood's dead at that point.
I had no idea.
Yeah, there's only a thin layer that's actively alive.
Whoa.
Yeah, that's
the spruce beetles, those little pests, are killing it.
So Yes, but
How
also,
dare they?
Technically, no, too.
Okay.
That's like another fun little tidbit.
Whoa.
Is the spruce beetles themselves, if it was just the spruce beetles, just Dendroctonus rufipennis, that's the Latin name.
Whoa
We're
there.
going to drop some Latin. I know, it's
Oh
scary.
my goodness.
It's a fun Latin name.
Dendroctonus rufipennis.
I know, it doesn't sound perverse at all.
Oh, I wasn't even going there, my man. Had no
But
idea.
most bark beetles in the genus Dendroctonus, which are the native ones of Western North America or North America in general, they
You
aren't
could say
the
Colorado.
ones that technically kill it. It's actually a fungus that they carry on them. It's called blue stain fungus.
Oh.
Yeah, and the way that this fungus actually kills the trees is it effectively like droughts them out. Like it effectively deprives them of water.
This much I knew, that the trees were somehow being deprived of their water source because of these beetles. My perception was that somehow there is like a channel that the water follows in the bark that goes up to the leaves and feeds the little leaves, and the leaves are what gives the trees food. And the beetles were somehow like causing a traffic jam in the part of the tree that gets the water all the way to the top.
That's almost like technically correct.
No
That's
way.
That's like really close to what is
Insane.
like technically what's happening.
Okay.
Like, there's just a little intermediary, and it's this blue stain fungus. So the beetles, if you look at that wood stain or like the post beetle kill furniture, you'll notice that like although there's a lot of tracks that the beetles make in the tree,
Yeah.
it doesn't perfectly circumnavigate the entire tree.
Not at all. It's very chaotic looking.
It's pretty chaotic, yeah, because there's a ton of beetles. In fact, it takes a ton of beetles to kill a tree. Like beetles can exist in these background states, which I'm sure will come up later, but
Background states.
yeah, it's sort of this background population level. And they can just sort of live in trees, and they actually can't kill a fully mature, sort of healthy spruce when it's just a few of them. They need hundreds, if not thousands of beetles to overwhelm a tree's defenses.
Okay.
And then what they do is they make all of their little homes inside the tree, and this blue stain fungus is what clogs up their vascular system. Like we have a vascular system, right? Our blood vessels.
Yeah.
Trees have a vascular system. In fact, most plants that we look on hikes have vascular systems.
Interesting.
And they have sort of two, instead of us having blood vessels, plants have what's called phloem, which...
And can I think I might know the second word.
Yeah?
Is the second word xylem?
The second word is xylem.
What's up, dude?
Yeah, xylem goes up, too.
Okay.
So there you go.
Wow. And I knew that. Of course I knew that.
Obviously, because you had the perfect sequitur. So xylem goes up, phloem flows down.
Okay.
And so xylem is what takes the water from the soil up into the needles of a tree. And it's both the phloem and xylem are operating in this thin layer of vascular cambium, which is sort of a technical term we don't need to know, but it's basically
It's only a little technical.
the live layer in between the bark and the wood.
Got it. That one part of the tree that is alive.
The one part of
Besides
the tree.
Are the leaves alive as well?
The leaves are alive. So this
Okay.
is just for the trunk.
Got it.
So the leaves are alive. The thin layer between the bark and the wood is alive.
And the roots?
The roots are alive too.
Got it.
Yeah. And the roots work in a very cool system. We actually know surprisingly little about roots because they're just so hard to get to.
That's cool.
So it's actually kind of shocking what we don't know about roots that we probably could know. And like there's experimental studies and a lot of like physiology stuff, but wild plants, ecosystem components of roots, sort of an untapped world that we're just getting into.
Wow. Let's get there on a future episode.
Absolutely, we will.
Yes, please.
But anyway, the blue stain fungus is what sort of prevents these trees from getting water, and they get droughted out. So their death lasts. It's kind of like a slow and tortuous death.
The tree's death does.
The tree's death is multiple years long.
Oh, God.
And so we actually have phases for this in the scientific community. So pre-outbreak we would call sort of like a pre-outbreak phase or like a green phase.
This is of the spruce beetles?
Of the spruce beetles. So when spruce beetle outbreak occurs across a landscape, we generally see it coming. Like we know that it's going to happen because we start to see spruce beetle populations growing in number and size.
Are they, can I ask maybe a dumb question before you get too far into it?
No question is dumb.
Well, is it analogous to like a cicada population, which famously like every 17 years or something, they come out of the ground and go crazy, or like locusts or whatever, like that kind of epidemic, like nothing, everything binary, or is it different than that?
It's pretty similar.
Okay.
And so it has a lot to do with how many trees are on the landscape.
A lot.
And a lot. Colorado. So when a lot of trees are on the landscape,
Is it a lot, actually?
There are a lot.
Okay.
Spruce beetles are really interesting. They have like heavy preference. They're kind of picky eaters.
Yeah.
When they are sort of in these background states. So right now in Colorado, after this outbreak, spruce beetles are still on the landscape. You can still find them out there.
Jeez.
But they're generally only predating on sort of old, already weak and dying trees that are too big to really defend themselves.
Okay.
Because when trees get really big,
themselves.
yeah, trees have defenses.
Okay.
So you'll see this in stages of an outbreak where there will be these pitch tubes, what we call it. It's basically like sap. So when a beetle tries to bore itself or like dig itself into the bark to get to that live layer between the bark and the wood, trees will notice that something's digging into them, and they won't notice in the same way we notice because they're trees. But we anthropomorphize them to make it easy. We make them human,
and it's fun.
It's fun. Just saying hi to your neighbor.
And they're
tree.
very wise as
They're
well.
Very wise, but they'll exude sap, and they'll.
Do they
try
have
and push them out.
Do they have like an immune system like us?
It's basically their immune system. Yeah,
Like a white blood cell kind of thing.
It's very analogous to that in an anthropomorphized way.
Interesting.
They just sort of automatically know that there's an invader at their door.
Yeah.
And they try and push it out. And it's the same way. It's like if there's just a few things trying to get you sick, our immune system, if we're healthy, does a good job. But if you're old, our immune system is tired. It doesn't do as good of a job.
Got it.
But if there's a ton of sort of pressure of this contagion or like these spruce beetles, our immune system gets overwhelmed. And the tree's immune system gets overwhelmed too.
Okay.
And so these spruce beetles sort of bounce back and forth between two population states, or like two sort of stable population dynamics, as I would refer to it. So they
asleep and awake.
Yeah, pretty much. They sort of have this background state, which is only capable of really damaging old, already sort of weakened trees. Maybe it was struck by lightning.
Yeah.
Maybe something else was causing it, like a mistletoe, and they're already weak.
What do you mean?
Yeah,
like,
mistletoe.
Is that a predator?
It's sort of a parasitic plant.
No way.
Yeah,
I didn't know that.
They'll suck the sugars right out of trees.
Like a strangling fig?
We don't have those in Colorado.
I was in Honduras recently, so I saw a lot of them.
Humble brag, but yeah.
Yeah, no kidding.
Pretty cool. Yeah,
it was pretty good. I went scuba diving.
Oh, wow.
It was nice.
There's no plants down there.
What? Really?
There's some beach grasses.
Yeah, in the ocean?
There's algae.
Algae?
Algae?
I say algae.
I think both are right.
Okay, thank you.
But they're not plants.
Algae's not plants.
They photosynthesize, but they're not plants.
I think I have another future episode. Okay, my dude. Tell me more.
About the plants?
Yeah.
Like
not the ones underwater. Let's skip the Honduras of it all.
All right, so
take me back.
The spruce beetles.
That's right.
So
I compared mistletoe to strangling figs. That's how we got here.
And we'll just end it there. But the spruce beetles, when there's a lot of what they would call sort of like a preferential food, or like a lot of hosts that they might want to sort of consume, they'll get these cues from pheromones. And
I'm like a Taco Bell beetle.
Yeah.
I'm a cheesy gordita crunch beetle.
A cheesy bean and rice burrito kind of beetle.
But nice and vegetarian.
Yeah, it's the most economical. They raised the prices from $1 to $1.20, which I talked to my mom, and she compared to a 20% increase, which made me even more mad. But
thanks a lot, Biden.
Thanks, Joe Biden. So these spruce beetles will oscillate between two stable population dynamics. And they're only semi-stable because when there's sort of after an outbreak, they've consumed all of their food, and they will preferentially choose spruce trees that are large diameter. So when there's enough spruce on the landscape that are above 42 centimeters diameter at breast height, which is just sort of
breast height.
Breast height. It's actually Gifford Pinchot's nipple height, which is a whole other sort of.
Of course, I know how high Gifford Pinchot's nipples are.
Yeah, it's like right about 3.5 feet.
I know.
Everybody knows.
I've seen them. I've measured them, of course.
I wish I could have seen
like
them.
Every schoolboy in America, I know how high Gifford Pinchot's nipples are from the ground.
Yeah, and so then you know the appropriate place to measure a tree's diameter.
That's right.
That's sort of the American forestry standard, is to measure its tree at breast height.
That
specifically
is fascinating.
Gifford Pinchot's breast height.
What did you say, 3.5 feet?
About, yeah.
Okay.
It's
Does that make Gifford Pinchot short or tall?
He's tall.
How tall are my nipples?
Probably about 3. He's about your height. He was like 6'2". Yeah.
Oh, thanks for telling everyone.
Yeah, just gotta advocate for you.
Listeners, I don't know if you got that. I'm 6'2". Wow. So I've got 3 foot high nipples. 3.5 foot high nipples.
Approximately.
Go on.
Mine are with my logging boots about same as Gifford Pinchot's. But they have this size preference because that's a big tree.
Size queens.
The 42 centimeters diameter at breast height is like, it's a pretty, like, you can hug it and not
quite get around.
Quite get around.
Why do they prefer a bigger tree?
Because it's just, it's free real estate. It's just
Oh, did they not like being around each other?
they like being around each other to a certain degree.
Okay.
Because if there's only a few of them, they can't kill a healthy tree.
Oh,
so
and
they
they don't want to kill it.
They do want to kill it.
Oh,
I mean,
why
they
do I
don't-
keep interjecting?
They kind of want to kill it. I mean, I don't know. That's sort of like imposing choice
It's
on these
to
bugs.
it's to their disadvantage to kill the tree.
It's to their advantage to like have it be very weak, because if it's a strong
Wow.
tree, the tree can just sort of push it out. It's like the immune system thing, right?
Got it.
Like they ideally don't want to like fully kill the entire forest, because then they have to like go back to these lower population states. But they have these aggregate and anti-aggregate pheromones that are incredibly complicated.
Wow.
So a spruce beetle will land on a tree. It'll say, oh, this is good habitat. It'll emit a bunch of aggregation pheromones to all of its friends and neighbors. And its friends and neighbors will come, and it'll just overwhelm the defenses of this tree.
Wow.
And then they'll make their little homes. They actually have very interesting life cycles that last 2 years. So they'll like overwinter.
It's kind of a long time.
Yeah, but as climates change, we see alterations to their life cycles
Wow.
to span only 1 year, because it's warmer in the winters and we don't get these same freeze events. So
They
it's-
do well with a freeze event, or they
don't
need
like
it?
a freeze event.
Okay.
So when it's really cold, they can't be out and about. But if it's not freezing over the winter, if it's sort of like a mild winter, they can sort of collapse their life cycle from 2 years to 1 year in certain instances.
Interesting. So here's the thing.
Mhm.
I'm failing to see how they're at all not the horrible thing that I perceive them as at the beginning of this conversation. How are they anything but really bad for the forest?
Yeah, so think of them as like not being like, I think bad and good are very like human terms, very subjective.
Yeah, okay, fair enough.
So these beetles have evolved on this landscape for centuries, if not millennium. So I mean, life and death are very like prevalent in nature, right? Things live, things die. They go through cycles.
And one is good and one is bad.
Yeah, obviously, because that's just the way all poets have written it.
Yeah.
So therefore, it is true.
Some poets think death is good.
The lame ones.
Oh, we'll talk about that on another episode, one that I'm hosting, where I'm in control,
Where
and
I'm
you
the
say,
poet.
"Teach me."
That would be very fun. I'd
Yeah,
love to
it
learn.
would be.
But these beetles have co-evolved with these ecosystems for centuries to millennia.
It's so crazy for me to wrap my head around.
And so, I mean, there's like some interesting thoughts, and this is an area of active research. And so I have some hypotheses on how spruce beetles may or may not interact with fire, because that was probably something you also heard about a lot.
Fires are bad.
Fires could be bad, but
Yeah.
fires could also not be bad.
Yeah, Trevor, before we get too far away from it, can I ask, like, historically, when was the last time there was an outbreak of spruce beetles?
That's a great question.
Before this, like, late 2000s?
So that is a really good question. It sort of depends on where you are.
Let's say Denver, Colorado.
Denver, Colorado. So Denver, Colorado is in the prairie,
'Kay.
So we don't really have spruce trees. But in the
Or,
mountains,
in
in
foothills,
Colorado,
mountains areas, Idaho Springs.
the 1960s. So generally,
60s?
we generally
That's
have,
why my dad didn't remember.
nobody remember. Well, unless your dad was born in the 1940s.
Why didn't my grandpa tell my dad to chill out about the spruce beetles?
Because he probably didn't remember either. Cause,
Wow.
Yeah. So these population outbursts where they're going from these background sort of endemic states.
That takes a long time.
It does, because think about it. They eat all of their food when they're in this sort of big population outbreak, this
Yeah.
epidemic state.
Yeah, that makes sense.
They consume all of their hosts, and then they have to go back down to this sort of lower level population state.
Wow.
And they oscillate between the two, and it takes the lifespan of the forest. Like for spruce to go from little tiny seeds all the way to big 42 centimeter diameter breast height trees. And that takes sometimes about a century, about 100
Wow.
years. Yeah. And
So then why do we get an explosion when these trees are like essentially middle age? If it's happening in the 60s and then it happens again in late 2000s, that's like are they quite at the age where they're prime spruce beetle prey?
it's an all you can eat buffet for them.
Fascinating.
It's the perfect size. They reach about 42 centimeters diameter at breast height or larger.
Oh, that's insane.
And so they like to have, they can't fly that far.
Oh.
So spruce beetles can't fly more than like, I think they can fly less than 30 meters. I need to double check that
Aw.
figure. They can't fly that far. So they need
Aw.
to have a lot of trees that are like pretty close together.
Okay.
And they can eat smaller trees. They can eat sort of younger ones. It's just not as good of food. It's not as good of habitat.
What's the name of the tissue they're eating?
They're eating the vascular cambium, I believe.
Oh, you said that earlier. Thank you.
Yeah, I'll have to double check that. I'm not a spruce beetle expert per se. I
Could've
more
fooled
study the like ecological implications.
Yeah.
Or have studied the ecological
Yeah.
implications, which are really interesting.
So I interrupted you when you were about to talk about fire.
It's sort of an area of ongoing research, and I have a lot of hypotheses. But
Yeah.
so a really interesting thing about spruce beetles that's quite like phenomenally interesting to me is they actually have been observed to increase the snowpack on a landscape in the decades following outbreak. This is kind of weird, right? So spruce beetles occur where they're spruce. They have host specificity.
Yeah.
So spruce generally.
My dad always said, where there's spruce, there's Bruce.
You know, I think there's probably a beetle named Bruce.
His friend Bruce goes to the forest a lot.
You know?
They have a place in Deckers.
I'd love to meet the man.
He's a great guy.
He seems like it.
Where there's spruce, there's
Bruce. But where there are spruce, there's generally high elevation. Or
Okay.
spruce generally occur at high elevation. And high elevation forests are generally pretty wet. And they're
Okay.
dominated by winter precipitation, which normally falls as snow, as we know
Yeah.
in Colorado.
Yeah.
And so pre-spruce outbreak, some of the snow gets intercepted or caught by the canopy.
Oh, I see where you're going.
Yeah, and
Okay.
so some of it makes it to the ground, but some of it makes it to the canopy.
Yeah.
And snow has this thing, and again, I'm not no snow scientist, but snow needs to go isothermal for it to melt, and so the entire snowpack needs to make it to the freezing temp, like 32. before it,
Isothermal, same temperature.
yeah.
Yes.
And so when it's on...
I know a lot about Latin roots.
You are really impressive.
I was a spelling bee kid.
Wow. I was a geography bee kid.
Wow.
There we go.
Makes good sense.
We have them all bases covered. So
Those are the two disciplines.
Those are the two genders.
Spelling and geography.
So when snow falls on a canopy, right, there's just a little bit of it, and it can go what's called sublimation.
Okay.
So it goes from a solid to a gas.
To a gas, yes.
And so it just sort of like evaporates off of the canopy of a tree.
Thus never bringing water to the earth underneath the trees.
No, it just goes right back up to the atmosphere.
Got it.
But as you probably know, with spruce beetle kill, and what I'll explain is in spruce beetle kill, it takes quite a bit of years for the spruce beetles or the corresponding blue stain fungus to kill the tree.
Yeah.
And so the trees go from
Forgot
green
about the fungus.
to red, and that's sort of what we call the red phase.
Uh-huh.
And that's when they're actively getting droughted and dying. And then they go what's called to the gray phase, when all of the needles fall to the ground.
Yeah, okay, I can speak to that actually. So like we would take hikes in beetle kill forests, and you could just like run your fingers along one of these branches with these coppery needles on them, and they would just like pop off.
Yeah.
Like they were barely attached to the tree at all.
Mm-hmm.
It felt like it felt terrible.
Yeah.
And again, I was really worried
Yeah.
when I was a kid.
So what the tree is doing there is trying to reabsorb all of the nutrients it can
By sucking them out of the
needles. Yeah,
Got
to
it.
try and like save energy and make it through the drought. But there
Got
is
it.
no end to the drought. They just die.
Ugh.
And then those needles fall to the ground, right?
Okay.
And that inputs nitrogen and phosphorus and whatever else you find in needles into the soil.
Yeah.
That sort of oscillates in a really cool way with the micro organisms in the soil. But what happens then is snow doesn't get intercepted by the canopy. It just makes it to the ground.
Right.
And that's a significant, I think it's about a 5% increase in snowpack,
Okay.
which doesn't sound like much, but when, you're covering massive landscapes, it's a lot of snow
Okay.
that makes it to the ground. And so in one specific instance on one specific forest, where this has been studied very extensively, there is evidence to suggest that there is an increase in snow following spruce beetle outbreaks.
Wow.
Mm-hmm.
Snow falling from the sky?
Falling from the sky, more of it makes it to the ground. And so because more of it makes it to the ground, more of it stays on the ground.
Okay. So it's good for skiers.
Potentially.
Interesting. Okay. What happens after that?
Well, we really don't know. We don't know if that water, like where it goes per se.
Yeah, what does that have to do with fire? That's what we were talking about.
Oh, that was what we were talking about. So this is an area, again, of active research, and this is some hypotheses that I have. So
Spring 'em on me.
Fire in this ecosystem is what we call like
good album
climatically
name.
driven fire.
Do you hear what I said? It's a good album name.
Climatically driven fire.
No, fire in this ecosystem.
Fire in this ecosystem. That is a good.
I would
That's a
listen to
funk
that.
album.
Yeah, hell yeah.
All right, we
There's
should
some
make
fire in this ecosystem.
that. There sure is.
Go on.
So there's basically like we think of fires in the biz as either being fuels driven or climate limited. So like in our lower elevation forests, and this is its own like little side bit, there's never enough like fuels to burn, and when there is enough fuels to burn, that's when it does burn.
Oh.
Like it's always warm enough to burn.
That makes sense.
But like there's not enough stuff to burn.
Yeah.
And so that's like fire suppression policies.
Detritus on the ground is what that means? Okay.
Yeah. Which that'd be a fun topic to talk about, like fire exclusion policies, specifically in California. That's a fun.
Yeah, I know you hate
tangent.
Smokey the Bear.
It's a complicated relationship. But then in high elevation forests, there's always enough stuff to burn.
Mm-hmm.
Like there's always a lot of trees and whatnot. The climate is really nice for growing materials and like growing fuels, but it's always wet.
Yeah.
And so it doesn't burn because, you need to have dryness to have a fire.
Yeah.
You can think of one of your many fire triangles, but you need to have heat for a fire to start.
Okay.
Right? And it's just always cool. So think about it.
I'm trying.
If you need to have like dry conditions to burn at high elevations, but after a spruce beetle outbreak, there's more snow on the ground,
which means less burning.
which means more moisture,
Yeah.
which means less
better
dry,
tree growth again.
potentially.
I should stop interrupting and let you tell me.
So essentially what my hypothesis is, and this is an area of active research, this is in no way, shape, or form sort of like proven or any evidence really to suggest a conclusive thing, but basically my thinking as a scientist is if there's more snow on the ground, which more snow leads to more moisture.
Yes.
More moisture means less dryness,
Agreed.
and we need dryness for fires.
We sure do.
So perhaps these spruce beetles are preventing fires
Yes.
indirectly.
Yes.
I don't know. We don't know. This is like an active area of research. Because again, these ecosystems at high elevation need dry conditions to burn.
Mm-hmm.
And so if there are more wet
But
conditions after
okay.
spruce beetles, maybe that's it.
Yeah. Aren't fires themselves an important part of an ecosystem's life cycle?
They sure are.
And then so spruce beetles preventing fires in whatever way they might do. Are you saying that's part of the fire cycle as well?
It could be. We don't know.
Interesting.
We don't know.
Because it lasts such a long time.
Yeah.
Like, how do you study a thing
Well-
that lasts this, like, 75 or 100 years? Like, how do you know?
Oh, what a good
I
question.
mean, there's no way we have enough data
Yeah.
about that to draw any real conclusions, right?
Well, it's long for us, but think about it for like a tree, right?
Not
So,
long
like,
at all.
I mean, it could be long. Like,
Yeah.
there's each tree will probably experience a disturbance event or two, right?
Wow.
And then they'll probably die. But these trees can live sort of uninterrupted for centuries. They can
Yeah.
live like 500 years
Wow.
or more.
That's
I
cool.
mean, the longest lived tree is over 5,000 years, or over 4,000, almost 5,000 years.
Methuselah?
Methuselah was cut down. Now it's like Prometheus?
Methuselah was cut down?
Yeah, it's like a whole scandal. That's another episode.
That's another episode.
But yeah, these
I hope someone's keeping
events-
track of how many episodes we've come
somebody
up
needs
with.
to keep us honest on it. Otherwise, we're just not going to do any episodes.
Yeah.
We're just going to drink wine at my house. So these events basically, like, they last a long time, right? They're longer than any human can live. So
Yeah.
what scientists do is we use what's called dendrochronology. We study tree rings, right? Trees
Of
remember
course.
things. But it's difficult if your disturbance event kills all the trees. Like spruce beetles kill all the trees.
Yeah.
And then those trees decay. So we don't have a good sort of record. And we actually don't have a really good, like, the scientific community does not have a good way of keeping track of previous disturbance events from spruce beetles. And so I have some thoughts with, like, the pollen record and lake sediments at high elevations. There's some sort of intricacies.
Some more like longer lasting evidence that
Yes.
doesn't decay.
Some sort of sediment records, which I'm not the expert on.
That's interesting.
But there are some, like, potentially interesting things. So the interesting thing, though, is spruce beetles are native to this ecosystem. They're native to the Intermountain West,
That is so
as
crazy.
are mountain pine beetles.
Yeah.
And there's just an active area of research. And they are native. Like, we know from previous research that when forests die, that there's a boom in understory cover. So, like,
Yeah.
the shrubs, the grasses, the other wildflowers underneath the canopy, they get released.
They suddenly have all this sunlight, all
Mhm.
this extra moisture, it sounds like.
Exactly. It's sunlight primarily,
Got
we
it.
think. That leads to these, like, massive booms. So, I mean, after a spruce beetle outbreak, they're phenomenally beautiful. Like, there's just so many
Wow,
wildflowers
I
in,
bet.
like, 10 years after.
So, okay, the long and short of it that I'm getting is like what we were upset about when I was a kid was this thing that we thought the mountains were supposed to look like was changing.
Yes.
And we thought this is so bad, it's not going to be the same. And ultimately, the forest is not supposed to be the same for a
No.
long period of time. It goes through these phases over and over and over, from pine beetle to, like, what did you call it? Undercover shrub, to all of these. Like, it's not going to look the same for a
No.
long period of time. And that's right.
Yes. So much like
That's
humans.
crazy.
Like, change is just natural for
Wow.
ecosystems.
Yeah.
Everything is consistently changing. And so we will go from what we think is what a forest is supposed to look like
Yeah.
to disturbance, but a forest is
But it turns out
supposed to
that's
get
just what
disturbed.
the forest looked like when we were kids.
It looked like that before we knew to sort of pay attention and romanticize what a forest should look like.
Wow.
And it will look like, with, hopefully climate change, whole other topic. But the forests look
I'm
like,
sure we can cover that in one episode.
yeah, at least.
No problem. No, probably just one.
At most. But forests are regenerating. They look like they
Yeah.
might be altering sort of their composition, but they are coming back to forests. And so they will be forests in the future. And so you can tell your dad tonight when you go home and see him and you tuck him into
Yeah,
bed.
I live with my dad. And I tuck him in at night.
That these forests are supposed to do that.
Wow.
And they will do that again and again and again for centuries to come.
I will tell him that. And a single tear will roll down his cheek. And he'll say thank you. Thank you, Alec. And thank you especially to your host, Trevor Carter.
Thank you all for listening. If you like it, let me know, and we'll make more of these. If not, it'll get buried in the ground, and this will be episode 0.
That's right. Follow us online at handle of to be determined in the future.
Mm-hmm.
And if you have any questions for the podcast, you can text Trevor directly at 1-800-TREESBOY.
All right. Thanks all.
Bye.
Bye.